All right, here comes more practice with finding the domain of a logarithmic function from its equation. In example 6b, the function is f of x is equal to log base 2 of x squared. Okay, the base of the logarithm is irrelevant. Okay, the rule for finding the domain of a logarithmic function is to, well, I wrote it up here. You're supposed to take the quantity that you're taking the logarithm of, set it greater than 0, and solve. Okay, so when you look at this, we are taking the logarithm of x squared. Okay, so we need to take x squared and set it greater than 0. Okay, so this is what we need to solve. The issue here is that this is a quadratic inequality. The highest power of x is 2, and we really haven't, well, we did talk about how to solve those. It was just that complicated process where you have to look at the graph. Okay, so I'm going to try to avoid that here, and let's just kind of reason through this. Okay, we are worried about plugging in an x value. We have to square the x value, and then that quantity we're taking the logarithm of. Okay, you cannot take the logarithm of something negative. You cannot take the logarithm of 0. Okay, so whatever you plug in for x has to be, once you square it, you have to get something positive or 0 as a result. Okay, so if you just try plugging in different x values, okay, if I plug in 1 squared is going to be 1, I can take the logarithm of 1. Okay, if I try x equals 2, I'm going to have to do x squared. That's going to be 4. That's going to be positive. I'm going to be able to take the logarithm of 4. Okay, let me do one more positive number. Okay, 3. I'm going to have to take, if this is my x value, I'm going to have to square it. 3 squared is 9. Okay, I'm okay. I can take the logarithm of 9. It's positive. Okay, so positive numbers are going to work. Okay, what about negative numbers? Okay, well, if I go to -1, okay, you're first going to square it. -1 times -1 is +1. You're going to be able to take the logarithm of +1. Okay, by squaring the negative, it becomes a positive quantity, and you're going to be able to take its logarithm. Okay, if you try a couple of other negative x values, if x were -2, you're going to have to square it to get +4. You're going to be able to take the logarithm of +4. Okay, -3, same thing. If I square it, multiply it by itself, I'm going to get +9. You're going to be able to take the logarithm of that result. Okay, so before you say the domain is all real numbers, there's still one thing we haven't checked. We've checked positive numbers, we've checked negative numbers, but we haven't checked 0. Okay, if x is actually equal to 0, you're going to get log base 2 of 0 squared. That's the log base 2 of 0. You're taking the logarithm of 0. You can't do that. Okay, so 0 is going to be the only bad spot here. Okay, so the domain is all real numbers except for x equals 0. Okay, so again, if you need to draw this out on a number line, okay, here's your number line. X equals 0 is your bad spot. You want to exclude it with an open circle. Everything else is good. Okay, so the domain here is going to be from, you can plug in x values from -infinity to 0, excluding 0. Those are the negative numbers. You can also plug in anything bigger than 0, not including 0. Those are the positive numbers. Okay, so your domain here, because of that square, because of your squaring x, you can plug in negative numbers as well as positive numbers. Okay, just can't plug in 0. Okay, all right, part C. The function is r of x is equal to 8 plus 5 times the natural log of 2x plus 3. All right, so there's a lot going on here. It's a base E logarithm. You've got a quantity, you're taking the logarithm of 2x plus 3. That's kind of complicated. You're multiplying the logarithm by 5, and then you're adding 8 to the whole thing. So there's a lot of noise, but remember how you take the how you find the domain of a logarithmic function. You only focus on what you're taking the logarithm of. 2x plus 3 here. You set it greater than 0 and you solve. That is it. Okay, so we're going to subtract 3 from both sides. That's going to tell us that 2x is greater than negative 3. We were just subtracting, so we don't need to flip the direction of the inequality. Okay, and so now if we want to get x by itself, we're going to divide both sides by 2. Since we're dividing by a positive number, we do not need to flip the direction of the inequality. Okay, so the x values that you're allowed to plug into this function have to be greater than negative 3/2 or negative 1.5, however you want to look at it. Okay, that's your domain. Okay, in interval notation, okay, draw your picture. Negative 3/2 is your x value you're looking at. You're not allowed to plug that in, but you can plug in anything bigger than it. Okay, so the domain here is going to be, if you go from left to right on your number line, okay, we're going to exclude negative 3/2, and then we can plug in anything bigger, so we'll go off to infinity. Okay, so here is the answer for this particular function. Okay, we got one more on the next page, so let's take a look at it. Top of page 6. Okay, in part D, the function is f of x is equal to 1 over the natural log of x. Okay, you got a couple of issues here. Okay, remember, a function can have multiple issues. This has a logarithm, yeah, but it's also a fraction. Okay, so you're going to have to look at the rules separately and combine the results. Okay, let's start with the logarithm. Okay, so here the logarithm is just the natural log of x. Okay, so here, you know, it's base e, that's irrelevant. Okay, what do you need to do? Well, the rule for finding the domain of a logarithmic function is to take the quantity that you're taking the logarithm of. Here it's just x. You're going to set it greater than 0. Okay, so from just looking at this, okay, you can only plug in positive x values. Okay, so I'm going to start drawing my picture, start drawing my number line. Okay, so far, okay, here's 0. We cannot plug in 0 because you can't take the logarithm of 0, but we can plug in anything bigger than 0. So I'm going to shade to the right. Okay, now we've got to deal with the fraction aspect of this function. Okay, what do we know about fractions? Well, fractions, you can't have 0 in the bottom. Okay, so we need to find our bad spot. The bad spot is when the bottom is equal to 0. Okay, so we need to figure out the bad spot. When is the natural log of x equal to 0? Okay, well, here's a way. Either, you know, this was actually one of the properties, so you may already know it from the properties, but here's how you can solve it. What makes ln go away? E. Okay, so one of the properties said if you take e and raise it to the natural log of x power, okay, that's the situation in which they cancel. If you go back and flip through the properties, e has to be raised to the natural log power. Okay, that's how they would cancel, and then they would cancel and leave you with x. Okay, so I'm going to take the left side and make it the power of e. Okay, so it's like the exponent of e. Okay, if I do that to the left, I have to do that to the right. Okay, so I'm going to take e, and then the right side becomes my exponent. Okay, so like I said, on the left, this property, let's see, this was probably back, this was probably, it may have, well, it was one of these sections. I forget if it was this one or the one before. Okay, this property, e and ln, they're side by side, they cancel, and they're going to leave you with just x. It will come down out of the power. Okay, it's going to be equal to e to the 0. Anything to the 0 power is 1. Okay, so the bad spot here is x equals 1. Okay, you can go back and check that. Okay, if you plug in 1 for x, you're going to get 1 over the natural log of 1. The natural log of 1, let's see here, natural log of 1 is 0. Okay, you can't divide by 0. Okay, so that's bad, bad, bad. Okay, all right, so That's the bad spot from the fraction, this 1x value. Okay, so we've got to go back and pool our results. Okay, because of the logarithm itself, the x values have to be bigger than 0. But now the fraction comes back and says, okay, but x can't be 1. Okay, so we're going to put 1 on the picture, and now we need to open up the point here. Okay, so at x equals 1, we need to put an open circle, okay, because x can't be 1. Okay, all right, so to write down the domain, just write down what you see on the picture. Okay, if you go from left to right on the number line, you're going to start at 0 and exclude it. You're going to walk until 1. You're going to exclude 1 with a parentheses. You'll pick up on the other side of 1. You need to keep it excluded. And then you're going to go off to positive infinity. Okay, this is the domain of this particular function. Okay, and I can even write it in words to help you, interpret this. Okay, the domain here is all real numbers strictly bigger than 0, excluding 1. Okay, so that was a tough one because not only did you have the logarithm, but you had the fraction. Okay, so going forward, just remember the rule. This is another domain rule. Okay, to find the domain of any logarithmic function, you need to take the quantity that you're taking the logarithm of and set it strictly greater than 0 and solve.